In this video for Math 94, we will be covering material on homework number 7, which covers section 9.5 and 9.6. This is about the graph of quadratic functions, and it's like problems 13, 14, 15, 16, 17, 18, 19, and 20 in the homework set. So, let's get started. I'd like to take a look at graphing these. Now, I could ask you to graph them by hand, but because of time, let's use our graphing calculator. So I'm going to bring my graphing calculator over here, and I'm going to hit y equals. Turn it on first. Then I'm going to hit y equals. Clear out what I have. Then I'm going to type in x squared for the first one, and then x squared plus 2. Because I'm just trying to evaluate these, I'm going to use a standard window, so I'm going to hit zoom 6. There's the graph of x squared, and then it's the graph of x squared plus 2. If you look at this, you'll see that it looks like the graph of x squared plus 2 is just the graph of x squared, except that it's moved up 2 units. And if you look at the original equation, you'll see the only difference between x squared and x squared plus 2 is that you have this plus 2 right here. Now I'm going to add one more graph to that. I'm going to add the third one, which is x squared minus 2. And we'll graph that now. There's the first two, and there's the third one. So this was x squared plus 2, x squared minus 2. Excuse me. So the difference you can see from x squared to x squared minus 2 is nothing more than a shift downward of 2 units. So what would you think the graph of x squared plus 3 would be? If you think about it, it should be the graph of x squared, but shifted up 3 units. Let's check that. I'll do x squared plus 3, like this. When I graph that, you'll see that last one is just the same as x squared, except it's shifted up 3 units. You can summarize this with the following statement. The graph of y equals x squared plus k is the graph of y equals x squared, shifted vertically k units. Of course, if k is positive, that's a vertical shift up. If k is negative, that's a vertical shift down. Now let's take a look at a different set of graphs. So I'm going to use my graphing calculator again to help me. So I'm going to clear out this and this and this. And I have x squared, and then I have parentheses x minus 1 quantity squared. All right, let's try these. I'm going to go to my same window, so zoom 6. There's x squared minus 1 squared. Now you notice this didn't move vertically but horizontally. And if I make the window just a little bit smaller, and I think I will, there's x squared, and there's x squared minus 1. And you see that it's just a shift of 1 unit horizontally in the positive direction. What if I put x plus 2 quantity squared in there and graph that? That's a shift 2 units in the negative direction. So what do you think x minus 4 squared would look like? Well, let's take a look. X minus 4 quantity squared. Graph this. That's a shift 4 units in the positive direction. So we can summarize this with the following statement. The graph of y equals x minus k quantity squared is the graph of y equals x squared shifted k units to the right if this number is positive, like it was in x minus 2, x minus 1, and x minus 4 quantity squared above. It's shifted k units to the left if k is negative. Now, if k is negative, you would get something like x minus negative 2, which ends up doing x plus 2. So that's a shift to the left k units. One last thing to play around with here on our calculator. We're going to look at these graphs. So I'm going to go back to my window, my graphing window here. I'm going to clear out all this stuff. Let's put in x squared, 2x squared. And I'll just do a standard window again. There's x squared, 2x squared. If you look at this, the graph didn't move from its position at the origin at all. All it did is go up in a quicker fashion, or we might say steeper. Now it turns out that's steeper by a factor of 2. If you plug in the value 1, x equals 1, into x squared, you get the answer 1 squared, or 1. If you plug in the value 1 for y into y equals 2x squared, you get the answer 2 times 1 squared, or 2. So that's a increase by a factor of 2. What if the number is smaller than 1, like 1/2? 1/2 x squared. I'll put in here now and graph this. You'll notice that that's not going up quite as steep as x squared. In fact, it's going up half speed, if you want to think about it that way. If you plug in x equals 1 into y equals x squared, you get an answer of 1. If you plug in x equals 1 into y equals 1/2 x squared, you get an answer of 1/2. So it's less steep by a factor of 2. And what if there's a negative number in front of this? Let's put this minus x squared, and I'll graph. You'll notice that that's just x squared reflected through the x-axis. We can summarize this in this statement. The graph of y equals ax squared is the graph of y equals x squared. Steeper by a factor of a if a is greater than 1, less steep by a factor of a if a is between 0 and 1, and reflected through the x-axis if a is less than 0. Now, on your homework, you have problems like this. It says the graphs below have the same steepness as the graph of y equals x squared. Identify the equation of each graph, name the shifts, and check your answers on your graphing calculator. All right, so here's the graph of A right here. You'll notice this has the same steepness as y equals ax squared, but it is shifted 1, 2, 3 units to the right. So I would say that the equation of the graph of A is y equals x minus, well, that's shifted 3 units to the right, so that's minus 3 quantity squared, or simplifying that, that's x plus 3 quantity squared. The shift here from y equals x squared is 1, 2, 3, 4 units to the right, so that would be y equals x minus 4 squared would be my guess for that one. Now let's check. I'm going to go back to my graphing calculator. I'll clear out all of this. So I'm going to put in x plus 3 quantity squared and x minus 4 quantity squared and see if I get the same answers. There's x plus 3 quantity squared. There's x minus 4 quantity squared. Notice x plus 3 quantity squared is a shift to the left horizontally 3 units. And x minus 4 quantity squared is a shift to the right horizontally 3 units. So that's how we would do that problem. Now let's take a look at this one and see if you can do this. You might choose to pause the video and then come back to it when you are finished. Looking at the graph of A has the same shape as y equals x squared. But you'll notice that instead of starting at 0, 0, it's starting at minus 3, minus 2. That's a shift horizontally of minus 3, or a shift to the left of 3, and then a shift down of 2. So if I think about this, I start with x squared. This right here is a shift horizontal left 3 units. And then I shift down 2. So this would be the equation I would say matches A. For B, you'll notice that it's the same as x squared, except it's shifted right 2 units and up 1 units. By the same notion, for B, shifting right 2 units would be x minus 2 squared, and then shifting up a unit, x minus 2 squared plus 1. So, and you can verify these on your graphing calculator. Let's go on to a different type of problem, and that's this. Describe how the graph of the equation might be obtained from y equals x squared. Use complete sentences and describe all shifts or translations to get y equals x minus 3 squared plus 4. To obtain the graph of y equals x minus 3 squared plus 4, we're going to have to shift, well, again, if you start with y equals x squared, to get to y equals x minus 3 squared is a shift horizontally 3 units to the right. So this is a shift horizontally 3 units to the right. But we're not done yet. We need to get from here to this one. So how do I change from x minus 3 squared to x minus 3 squared plus 4? The only difference here is adding 4, so that's going to be a shift vertically 4 units. So to move from x squared to x minus 3 quantity squared plus 4, you shift horizontally 3 units to the right and shift vertically 4 units. This right here is the correct graph right here, this first one. Okay. Now, let's talk a little bit about the vertex form of a quadratic function. You might notice that in all of these problems, the vertex is pretty easy to read. Y equals a x minus h squared plus k is called the vertex form of a quadratic function, where hk is the vertex. Think about this problem. This problem right here, the vertex is going to be y equals a x minus h squared plus k. Here, h is 6 and k is 0. So the vertex should be at 6, 0. Let's take a look at this graph. I'm going to try to graph it on my graphing calculator. So I'll clear this out. I'll put minus x minus 6 quantity squared. Okay, I don't have to put the plus 0. I'll use a standard window. And you can see the vertex is at 6, 0, just like we predicted. Where would the vertex of this one be? Again, y equals a x minus h squared plus k. Here, h equals 2 and k equals negative 3. So my vertex here should be at 2, negative 3. You'll notice that if this is minus h, the x-coordinate of this is 2. If we had an additional problem like this, this can be thought of this way. Since x plus 3 is the same as x minus negative 3 squared, then here h is negative 3 and k is negative 1. So my vertex should be minus 3, minus 1. Now, for a final type of problem that you'll encounter on the homework, let's take a look at this one. Find the equation of a parabola giving vertex and another point. Okay, we're going to use this vertex form of the parabola because you are given the vertex. The vertex is 5, negative 1. So I will replace 5 for h and negative 1 for k. The only question here is what is a? To find a, we substitute the values minus 3 and 3 for x and y and solve for a, and then write the final equation. So let's do that. 3 is y, and minus 3 is x. Now remember the order of operations here. Do the parentheses first. That's going to be negative 8. Now, that would give me a equals 64. A times 64 minus 1 equals 3. So let's add 1 to each side. And it gives you 4 equals 64a. So a equals 4/64, which can also be thought of as 1/16. So my final equation would be y equals a, which is 1/16, x minus 5 squared minus 1. There's my equation of my parabola. Why don't you try this one, very similar problem, on your own, and we start the video when you are completed. So y equals a, x minus 8 squared plus k. So that's a, x minus -1 squared plus k, or a, x plus 1 squared minus 5. Now to find a, we plug in our point 1, 7, 1 for x and 7 for y. Doing the arithmetic here, this is 2 squared, or 4a minus 5 equals 7. Add 5 to both sides. Divide by 4. And a equals 3. So my final equation is y equals 3x minus -1, or x plus 1 squared, minus 5. I hope you have found this video useful.